Well, hello everybody, and welcome to part 2 of our SA9100 TX9100 old married couple video. In part 1, we kind of did a little introduction to these two components, and we did the restoration and the repair and a little bit of troubleshooting on our SA9100. And by the way, I did do a quick listen to it on a set of speakers, and I played, I don't know if you guys will all be familiar with this song, but I played a song by an artist named Robert Plant from Led Zeppelin, and off of his Principle of Moments album, and it was a song called In the Mood, and I really liked that song. I liked the recording. And I will tell you, that SA9100 was just fantastic. I could not believe, I know I talk a lot about my bad ears, that I just can't hear the high frequencies the way I used to when I was younger. And I heard things from that amp that I have not heard in a long time from other amplifiers. And that includes that AdCom and my, even my SX 1050. It just didn't quite have, it just didn't have the range and the clarity that SA. I really know why the SA9100 has the reputation that it has now. Now that I have one that's been properly aligned and properly restored, and I had a chance to listen to it, I can't tell you how impressed I was. So hey, let me open a can of worms with all of you. I'm going to make a suggestion, and you guys can go in the comments and maybe give me some of your suggestions. My cousin, many years ago, had a set of speakers called by a company called Rectilinear, and they were the Rectilinear 3s, and they were called the High Boys. And maybe I'll try to find a picture of them and pop it up here, picture-in-picture for you. But in my mind, it popped up that I think that would be a great combination to put those speakers to hear that amplifier with a set of Rectilinear 3s in really good condition, High Boys. I don't know, tell me what you guys think. There's so many speakers out there and so many opinions, and I'm sure I'll get all kind of comments on that if any of you have ever heard of those. But that's just one thing I thought of. That's all, just a thought. But yeah. So here we are with our TX9100, and it is in every bit as good of condition as the SA9100 we serviced. This one has a little bit more dirt on it by the looks of it, not much, but the owner reported that the tuning meter is not centering properly when you're centering on the station, and it seems to be not as sensitive as it used to be. So just it could be alignment, it could be, who knows. So the first thing we want to do is we want to turn this on, and of course we're going to give it the works. We're going to go over and restore it and align it. So if that sounds good to you, stick around, because that's what this video is going to entail. And then hopefully at the end of this video we should be able to put the old married couple back together and see if they can still make beautiful music together, huh? Alright, so let's get this thing hooked up and give it a listen and see where we're at. Alright, so we're all hooked up. I'm using my little Lepi Class D amplifier and my little bench speakers, and we have the outside antenna hooked up, so I have a fairly decent antenna. So we're going to turn this on and let's see if the tuner will tune. Oh yeah. I could see what he says about the meter. So you can see how the meter, when you center it on the channel, the meter is not centered, so I see that. From an alignment standpoint, I'm barely moving this tuning knob, and I'm getting stations down here in the in the hole.
It supports the creation of an independent Palestinian state. The U.S. has long supported. You can never sound of the thousand.
Well, now it is centering. Well, okay, so far so good. I'll do some more testing offline. Let's kick it on to AM. Now I can tell you on the AM, there's no signal down here, so I don't expect to hear much, but at least we can see if it picks up noise. Oh yeah. Yeah, we're not going to get much down here right now, especially under the bench with all the things turned on the bench. But it does work. It is tuning. The dial lights all seem to be on. It's very well lit. If I shut this off, I mean, you can kind of I'll turn the bench lights off here. You can see how nicely illuminated it is. So that's beautiful. I don't know, just my first preliminary checkout, I've got to say that this tuner is in very, very good condition. Might need a very slight touch-up on the alignment, if any. We'll do the recap on it, obviously, and clean it really well. But I think this one's not going to be that big of a challenge to get it really working peak performance. These are fantastic tuners. The way they're put together, they're a little bit finicky to work on. I think the alignment can be a little bit touchy because of the way these are put together. But for analog, this generation of tuner, fantastic tuner. Every bit on par in tuning capabilities as the SA9100 is in amplifying capabilities. So. Okay, so let's take it apart and do some cleaning and some testing, and I think this might be a really nice restoration. We have the cover off now, and you're seeing what I'm seeing for the first time, and you can just see, I mean, yes, it's dusty and it does have some corrosion on it. It looks like it got some little bit of water in it or something at one time. Let me pull you off of the camera mount for a minute. If you look to the side, we do have some rust damage, so that's going to need a little bit of derusting. But other than that, it looks rather dusty. But you saw it, folks. I mean, this thing worked just almost flawlessly. So. You know, now as you can see, this kind of reminds me a little bit of how Marantz does theirs, is they put everything in shielding and they mark everything very clearly what it is, what it does. So just a beautifully, wonderfully built device. They did a great job on this. Now, one of the unique things that was in style in the 1970s, and they kind of got away from it now, you don't see it so much. And this might be, since we don't have a whole lot of restoration to do and troubleshooting on this one, or alignment, I thought maybe we would do something a little different on this video, and we would take a look at these two jacks here called FM Multipath. Now, multipath is a definition for when a radio signal reflects off of an object. So when you receive something on a receiver, you can receive the direct signal that's coming directly from the signal source, and then you can receive a reflected version that's kind of off time. In other words, it's delayed timing from the original signal. And by receiving the same signal, once direct and once reflected, what that means is the signal is coming from two different paths, hence the word multipath. So multipath is actually a bad thing. It's something you don't want because it's going to cause distortion in your sound, in your signal. So what they've done in these higher end receivers is given you a means by which you can, for this particular device, you can connect an oscilloscope to these two terminals and put it into XY mode, and you can actually see the radio signal or a representation of it. And it allows you, of course, the antenna of choice at the time was the FM dipole antenna. Those are the big antennas that look like a shape of a T. So you have two wires coming up, like twin lead wire coming up off of your FM terminals, and then they branch off to the right and to the left. And those dipole antennas can be quite directional in some ways, and they can receive the multipath signal, but also, since they're directional, they can be turned and positioned in such a way to reject the multipath signal or the reflected signal and receive the direct signal. And these terminals will allow us to be able to do that. So maybe we'll do a little playing around now. Of course, where I'm at, I don't have a very good place to receive FM stations with an indoor antenna, let alone the multipath, but we'll see what we can do if we can at least demonstrate what the signal looks like, and maybe go on location somewhere where we can test it. I don't know yet. We'll think about that, but I think it might be some fun to play around with that a little bit, just to give you guys because a lot of people ask me about it. What multipath is. I know there's a lot of confusion about it. There are multipath switches on the front of some radios, and it's just a different way. It'll actually allow you to use the signal meter or the tuning meter to look at a representation of the multipath signal, to null it out. This is a much more elaborate way, because it lets you actually look at it on an oscilloscope. And of course, I think even Pioneer did sell an external scope that you could buy, and it would not only show you the patterns of your audio from your amplifier, but it also can tie into your multipath. I think there is a model. If I see it, I'll mention it. But I thought I saw one somewhere being advertised back in the day. But anyhow, that's something we'll look at. So back to this. As we saw, dirty needs cleaned, and rusty needs derusted. And so looks like some of the restoration we're going to be dealing with here is a lot of cosmetic things. But certainly electronics wise, I'm not going to play with very much. I'll do a basic recap on it just for future proofing it a little bit. And I'm going to leave well enough alone. Other than that, the receiver is working very well. We'll put some test equipment on it to just see how things track, and we'll go from there. So let me get this cleaned up a little bit and then get some things apart, and we'll play around from there. Okay, everybody, doing a little bit of handheld camera work. I just thought you'd be interested in seeing what's involved in doing a quote-unquote recap on some of the equipment out there. And this is one of the more challenging ones, so I thought this would be a good place to stop for a second and turn the camera on. If you look, right here we have our FM AM tuner board, and you can see you have to disconnect all these wire wraps from here and loosen all the clamps for the wires here to be able to swing this out. And even at that, you have to be very careful. These little coaxes will break so easily because these are all solid wires. They can't bend too many times or they'll break. And then the other thing is you can only get it up about this far to get the desoldering iron in there. And then once you do that, this plate is in the way, so you have to partially disconnect that to drop it out of the way so you can get in there and do a proper job. The time, for replacing $10 worth of capacitors or so. And by the way, there probably are. There's quite a few. You can see all the caps that are on here. It takes quite a bit of effort. It's very delicate work, and you don't want to move any coils that may be on here. You don't want to move any of the adjustments. Remember, this stereo was very well aligned when we started, so I sure don't want to deal with, affect any of that. So you got to be very careful. But I just wanted you all to see what's involved in recapping these. Now, we can get into debates about, is it worth recapping one of these or not worth recapping? I'm on the fence sometimes. With a really high-end collectible piece of gear like this, that the owner is intent on using this for many years to come. This is his main system in his house. It has sentimental value as well as actual value. He wants to be able to pass this on to his children, possibly. To me, this is an insurance policy that it'll keep running. These Nippon Chemicon capacitors that Pioneer used are of very high quality, and they may last many more years. We don't know, but I have seen them leak. Not as often as some of the other gear that's out there, and if you don't care about this stuff, you can fix it yourself easily and you don't mind, well, then you could probably get away with not doing a recap. But in this instance, I think the owner made the right choice, and I think it is well worth putting the time, effort, and money that that it needs to do this. So I just wanted to show you all that that some of this gear can be rather challenging to do this. And you certainly need the right tools for the job. You could see all of the soldering and desoldering gear that I use. So just for those of you who've never done this or who are considering doing this, there's right ways and wrong ways to do it. And the right way is really to take it apart carefully, take pictures, test everything, be very careful not to move anything on the board, and then very carefully remove each of the capacitors and replace them. And if you don't have the proper tools, it might be a lower risk just to leave well enough alone, unless there actually is signs of the capacitors leaking or problems with sound cutting out or poor performance. So that's really all I'm going to say about that. I'm not going to say for or against recapping. I think in this instance it's a good thing, and I understand certainly why some people don't want to do it. But again, I'm happy that the owner chose to do this, because I think this is going to turn out to be a great tuner, and it's going to last many, many years to come. And I think it has great performance, great sound. I think you'd be hard pressed to find anything better out there today. Some of the new digital PLL tuners are fantastic, but there's just something about that blue dial and having that knob and kind of hearing the station fading in as you tune in on the center of it. It's just something nostalgic about it, at least for me. I enjoy those kinds of things. So anyways, I'm going to get back to work here. I just thought you'd be interested in seeing this. And when we come back, I'll have this all recapped, and we're going to start checking the alignment. And hopefully that's all we're going to do is check it, because it looks like it's pretty close. I don't think we're going to have too many things to adjust on this thing unless my fumble fingers mess something up, which that can always happen. What's the saying? Failure is always an option. So anyhow, all right, we'll be back. Well, looks like I spoke too soon, guys. The first capacitor I pulled out of this board, if we can get in close here and look, come on and focus. you can see it looks like it might be leaky, and this is not flux. I did check that. It's not flux, and it is certainly not glue, because this capacitor was not glued down. And when I look very closely at this lead, I can actually see, you know, going clear up into the lead and it getting tarnished. So this capacitor was starting to leak a little bit. Again, these Nippon Chemicons are pretty good capacitors, but still, remember, this thing's 1974, so, you know, you're talking a 40-plus year old piece of equipment. So you just know that these things just are going to have a shelf life. So there's the case for recapping. You know, this was not there yet. And you can see right down here where I'm looking at. I don't know if I can zoom in. I know I'm hand holding the camera here, but if you look kind of closely, there we go. You can see some of the crust there. I've wiped some of it off already, but not a terrible leak by any means, but definitely showing that, you know, this was a good choice for the owner of this device. So, all right, enough talking. We'll be back. All right, we have most of the recap done here. Just got some progress going on, and could finish up the multiplex board and put all this back together, put the shields on, and then we're going to give it a little test. Inside here is your actual local oscillator and all that, and I have not taken that apart yet, but I will. There's probably a couple capacitors in there, but I don't know if I'm going to mess with this too much, because this is some of the critical adjustments in here. So we'll see how it goes. All looks good so far. I think this is turning out really well. I thought I'd take a second here to show you guys the tuning gang and the front end, the RF front end to this tuner. It's really pretty amazing how they did it. When you look at how this thing's put together, this is more like you would see in like a ham radio or, you know, a commercial grade radio. When you look at the ground plane and how they mount all the components in there, and you look at the, you know, the tuning capacitor, you look at the shielding, this heavy metal shielding, you can see they really spared no expense on this thing. That's why these things are so impressive to me. This was an era where people were willing to pay, you know, and these companies were willing to build things to this high end. Now there still are manufacturers out there who make gear of this quality. I would say you'll never get the metalwork and things that you get today, but that there is high-end gear. But you know, you start getting into the boutique things that can match what this equipment does, and you can easily drop many thousands of dollars. I've seen amplifiers that are selling for $5, $10, even $20,000. Some of the boutique amplifiers out there. And same thing with tuners. You know, you can get $2,000, $3,000 in a tuner, and you know, it really gives you respect for what these folks were doing back in the 70s. So yeah, we're putting it back together here and getting ready for some tests. Like I said, I have the new bulbs ordered for this. I'm going to do an LED upgrade. It's really simple in these tuners. The lamps, if you've never seen them before, look kind of like little AGC fuses, little glass fuses, but they're actually bulbs. So those should be in next week sometime, and I'll get those in. But in the meantime, we're just going to go through this and do some tests. Well, good morning, everyone. So got a little tied up yesterday, so it's the weekend and it's morning time, and I've had my cup of coffee, which is all good stuff. And I have this very precariously set up little experiment for all of us to play with this morning. So let's start out with what I'm doing, okay? First of all, the alignment so far on this thing is so perfect that I really haven't had to touch anything. Now, I haven't gotten into the AM a whole lot yet, because the most complicated part of an alignment is the FM. So before we get into, a lot of people want to just dig into the service manual and start going through the procedure, and you end up coming around full circle. You throw it way out of alignment and bring it all the way back around into alignment, and sometimes you end up right where you started. So, a little bit, I didn't get into this in the other videos because those receivers really needed alignment. So, but just a little test how I test these. And again, I'm sure there's a lot of you who are a lot better with tuners and RF than I am. So I welcome any comments. By the way, I mean, wow, you guys have been blowing up my site with the comments and questions. I do have my next video, I promise, right after this is done, is going to be a comments and questions video to try to address some of the many questions, comments, all these different things. And I will once again share with you an email address that if you have questions and comments, you can email me as well as message me through my YouTube channel. So anyways, let's get back to this. This tuner turned out beautifully. I really don't think there's a whole lot in the alignment end of things that I'm going to have to do to this. One of the things that the owner did mention with this was that he felt that when you tune this thing on signal, the tuning meter is not centered properly. In other words, when it's getting the best signal, the tuning's not always on center. We're going to get into a little bit of a couple things in tuners that you normally don't hear about, or that you may have heard but you're not really familiar with what it really means. So the first thing let's talk about is when you look at this alignment, you look at all the controls on this tuner. One thing I want to zoom in on for you is sometimes this is outside on the back of a receiver or a tuner, and in this case it's inside, and you hear the word de-emphasis, and it's always two settings, 50 microsecond and 75 microsecond. And what the heck does that mean? And invariably we've all flipped that switch, and you notice that maybe the sound changes a little bit, the tone, maybe it gets a little deeper sounding. So let's talk a little bit about what this is and kind of take the mystery out of it. De-emphasis can only take place, or should only take place, I say, if pre-emphasis has taken place prior to that. So what the heck is that? Well, in receivers, especially FM, when you're in the VHF band, which is where FM broadcast is, okay, so you're at 88 to 108 megahertz, roughly, depending on what part of the world you live. And invariably, you will get noise in your signal, and it comes in the form of static, hiss, different. It's described in different ways, but basically it's static. You know what it sounds like. And basically what everybody has come up with is a method to reduce the background noise of your broadcast signal. And the way they do that, just like with records, any of you folks who are into vinyl, who are into records, have always heard the term RIAA equalization, and it's basically you're changing the equalization properties of your preamp or of your record, basically to compensate for the way that a cartridge, picks up the audio from the groove in the record. Okay, so and I again, forgive me, I haven't done haven't looked this up, but basically it's changing the properties of the bass and treble frequencies of your audio to compensate for those losses or gains in the record. Okay, de-emphasis and pre-emphasis is for a similar reason. By boosting the actual audio frequencies in the high frequency spectrum, they can also filter the noise frequencies. So in other words, they're reducing some of the high frequency. Okay, that's called pre-emphasis. Okay, so that's done at the radio station. Okay, and the microseconds depends on what part of the world you live. In most of the world, they're putting a kind of a 50 microsecond, and guys, correct me on this, I'm not great in terminology here. Okay, I'm not by any means as big into broadcast and so forth as some other people, but basically we're putting a 50 microsecond RC time constant into the signal and applying it to the signal before you transmit it. And what it is doing is it is emphasizing the high frequencies and allowing you, which will allow you to reject the high frequency noise that's mixed in with it. Okay, does that kind of make sense? When you receive that signal, okay, basically you have to de-emphasize it. In other words, we want to bring our audio back to its original, what it was like when it was broadcast. When they were playing the record or the recording at the broadcast station. So what they're going to do is they're going to reduce that high frequency back down, so that basically it helps to reject the noise and still maintain the high frequencies of your audio. Okay, does that make sense? I hope I explained it right, because again, I'm not as good at these definitions as some of you out there may be, who are a lot more into broadcast and into this type of technology. But in most of the world, they put a 50 microsecond latency in there. In the United States and a couple other places, it's 75 microseconds. So tuners that are built for international trade, where they're selling them all over the world, will have switchable de-emphasis, so that you can set the de-emphasis to match the de-emphasis signal that they apply prior to broadcasting. Okay, so in our country, in the United States, it's 75 microseconds. So if we look down in here, you can see this is already preset to 75 microseconds. Okay, and they actually put a little, you see that screw in there, see it? And that little slider, they lock it in, because basically this machine was made for the United States to be sold in the US. We could easily take that screw out and slide that over, and it would work in, over in Europe, which uses 50 microseconds. Now, what would happen if we flip this switch here in the United States? Well, nothing bad would happen. All that would happen is it would change the equalization of the signal that you're listening to. So in the United States, what you would hear would be that it would be a little more bassy. So sometimes people will flip that switch over to 50, not realizing what they're doing and what it is, and it kind of will make your tuner sound, it'll have more bass, but it'll sound kind of muddy. There's been a lot of different definitions of how it sounds. Muddier, duller sound, thumpy bass, different things like that. And that's because the equalization is wrong, because you're de-emphasizing, the signal at a different rate than the pre-emphasis that's being applied. So if you want correct equalization of your stations when you tune them in, you want to make sure that this is set to the proper setting for your country. So in the United States, it's 75. If you're in Europe and I think Australia, places like that, it's 50. And conversely, in those countries, if you set the de-emphasis to 75 microseconds, it will do the opposite of what it does in America. It'll make the sound a little bit more hollow, a little tinnier, less bass emphasis. So it basically will throw off the equalization no matter where you are. So you want to make sure this is set properly. So this one is set properly. Now the other thing that we're going to talk about a little bit that's interesting is multipath. But before we do that, let's take a look at the setup that we have on my little precarious test equipment setup. For the main carrier signal, as you can see, I'm using my 8657, and all it is a basic, this is just your run-of-the-mill frequency generator. It's for RF. It can output AM or FM modulated carrier waves. So that's why I like this one, because it can do FM modulation as well as AM, and it can do external FM modulation, which is really good. Pretty much any RF generator that you have out there, even the lowest end, the little old tube ones like the ICO 324 or whatever, or like our one that we did over here, we did the little video on, they're all capable of doing AM modulation, but not FM. So that's why I like this one. So when I use this as my carrier wave, I'm set at 98 megahertz, okay, and I'm using my external FM modulation, and you can see I have a wire going into there, and that wire leads over to our SG165. And the SG165, if I can zoom in for you, you can see the SG165 is set to multiplex right now. So I have a standard multiplex signal coming out, and if you look at my little toggle switches, I have my 19 kilohertz pilot, and if you guys aren't familiar with the terms I'm using, go back and look at my FM multiplex video, and I have my right and left signals turned on, you know, for my modulation, 400 hertz. So, and it's going straight into right there into the signal generator and mixing in to this carrier signal. So all this really, at the end of the day, long story short, I've just made a mini FM stereo radio station that transmits a stereo signal with an audio of 400 hertz. So there's a 400 hertz tone being broadcast in stereo at 98 megahertz. Okay, so really, if we tune our tuner to 98 megahertz, we will receive a stereo signal that should turn the stereo light on, and it should have a 400 hertz tone. And you can see I just have a basic antenna, and no, this antenna is not resonant to 98 megahertz. Okay, that's not very important unless you're trying to deal with you know, you want to deal with output levels and things. This is not going to be accurate because we're non-resonant and all kind, but we're not going to worry about that. We're just transmitting a basic signal. I also have this blue wire, which is a random length piece of wire that is going into the tuner. And again, yes, you can cut this to a resonant length of 98 megahertz, and you know, the problem is anytime you take an antenna that's floating like this, which is basically that has no ground plane, and you float it in space, anything around that piece of wire will affect its resonant frequency. So it's pretty useless to ever cut a wire to total resonance, because you're going to throw that off as soon as you move the wire or move anything near it, or even you walking near it acts as a capacitor and you change the resonant frequency. So none of that's very important. Really, we just wanted a means to transmit the signal and a means to receive it, which is what our two little wires are. And this just goes into the FM wire, okay? Now, if I give you shaky cam for a minute, you can see I've tuned it in, and you can see how close this is to being on frequency. I've not done any alignment to this thing, and boy, is it on, you know. We have our stereo light. We have 98 megahertz. We're almost right on that, very close. We have the tuning, as you can see, is centered. Okay, more about this here in a little bit. And we have full signal strength. I'm at negative 10 dB, which doesn't mean anything, remember, but basically I have a strong FM signal that I'm transmitting. And we're tuned in. And if we turn up our little amplifier, you can hear that we're receiving a very clear signal. And you can see, if I move my wire, you can hear how it gets kind of staticky. And if I turn it down, see there? Okay. All right. Okay. So, why am I showing you all this? Well, first of all, by setting up this little station like this, and I'm not invasively wiring my test equipment to the tuner. In other words, I am replicating the real world scenario where there is a FM signal being broadcast, and I'm using the antenna lead to tune in that station. And if everything is aligned properly, okay, and some of you are going to say some things, you tuner guys, let me address it here in a minute. I should be able to, A, tune on frequency with my dial. Shaky cam coming again, warning. I should be able to be on frequency with my dial, so that's going to tell me if my dial setting is proper. I should have a relatively strong signal strength when I get a quiet signal. And my tuning meter should be centered if I'm getting a full strength signal. And if, you know, with my multiplex signal setup, I should trigger the FM pilot. And I should even, I don't know, this is a stereo camera, so maybe you can hear it, but let's turn the sound up. And if I turn my left and right signals on and off, there's left, there's right. You hear that? So that tells me that my multiplex signal is working very, very well. Okay, so without even taking the radio apart, without even getting invasive into the circuitry, just by setting up this little mini radio station, we can simulate the real world under some somewhat controlled conditions and at least know if everything's working properly. Now, those of you who are really into RF and into tuners will know that this is not going to tell you everything. Okay, if we want to measure distortion and things like that, you know, we want to make sure that the discriminator is centered and all that. This is not really going to tell you that definitively. If this sounds really good and everything's working properly, you can at least have some level of confidence that it's really, really close. Okay? This is not going to allow us to know that it's 100% perfect. That would only come with going through the process of doing the alignment. But the reason I do this ahead of time is if I see this performing as well as it is right now, I already know that it's going to be darn close. It's not going to, you know, even if there is the tiniest little bit of, you know, misalignment, I know that I'm probably not going to want to go through and do the entire alignment from start to finish. I'm just going to want to check all my little points, make sure they're working properly, and if something needs the slightest little adjustment, I'll make it. And then that way I have control over where I am and where I'm going. When you do a full alignment, starting from step 1 and going to step 50 or whatever they give you, you're going to find out that you could throw things way off before you bring them all around full circle back in. And that's a big job. It takes extra time, and you may not need to spend that time. So if a tuner is working properly and it passes this first test, we can kind of skip over the whole process of starting at step 1. We can just kind of go through and spot check parts here and make sure they're all good. Like one of the things I'll do is, you feed a 10 megahertz sine wave, just a 10 megahertz carrier wave with no modulation into it. And if this is a discriminator based tuner, which this one is like this, you can measure your discriminator, and your discriminator voltage should be null. It should be 0. That shouldn't be positive, it shouldn't be negative. And there's a little adjustment, and sometimes that might be the slightest bit off. And in all honesty, it can be a little bit off, and most of the time you won't notice the distortion. If it's too far off, it will cause distortion that becomes audible to you. But again, little things like that. So let's talk a little bit about these funny little jacks that are on the back of a lot of tuners. And I've heard a lot of confusion. I've read a lot of things on the comments, of forums and things, and it's surprising how much people get confused about what it is. I've even seen people give recommendations that this is where you connect your signal in, or whatever, and I'm like, no, that's an output. It's not an input. Okay, so and what we're talking about is multipath. Okay, we touched on this earlier in the video a little bit. What is multipath? Multipath is basically the reflection of a signal off of an object. So, and maybe I'll try to put up some graphics here for you. Little hint to me to do that when I'm editing the video. So I have this building, and I have my radio station. Okay, so here's my radio station, my antenna, and I have my tuner right here, let's say. Okay, so let's set our tuner here. Okay, terrible props, huh? So this antenna will broadcast the signal, the station, and the direct route would be from this antenna to your receiver. So that's your direct path. However, this big building will reflect some of that RF. So that RF will leave this antenna, strike this building. Some of it will penetrate the building. Some of it will reflect off of the building at an angle and come back to here. So, and if you notice, even though RF travels at approximately the speed of light, the distance from here to here is shorter than the distance from here to here to here. So there's actually going to be a delayed or echoed signal that will come through your tuner slightly after the direct signal applies it. What that's going to do is that's going to cause like a beat frequency that is going to distort your signal. So a lot of times when you hear, you're tuning in a station, you just can't seem to tune it on. You turn the tuning knob all over the place, but it just never tunes properly. It always has this distorted kind of weird sound. It's because you're picking up multipath. You're picking up the signal at two different times, the direct time and the reflected time, and they're just close enough to one another. They're both, remember, they're both the original signal. So if it's 98 FM, 98 megahertz, both of those signals are still going to be 98 megahertz. It's just that the direct one will arrive at your tuner sooner than the reflected one. So you have two 98 megahertz. It would be like having two separate tuners broadcasting a slight time frame apart from one another into the same tuner at the same time. You get like an echo. Now, it's not an echo you can hear with your ears because it's so close together. We're talking, you know, microseconds or less. But what those signals will do is, since they're out of phase now, they will cause a phase distortion and cause the signal to sound distorted. So what the folks have come up with was multipath measurement, a means to be able to look at the multipath signal. Now, the easiest way to deal with multipath is move your antenna, okay? So here's our antenna, all right, and we're picking it up relatively good now. I purposely turned it down a little bit. You can hear a slight amount of static, okay, and by moving this around, I can be picking up interference from other objects, and I can also be picking up a reflected version of that signal. Okay? Now, again, the easiest, the simple way is move your antenna until you get the best sounding signal, right? But, of course, all of us audiophiles just can't be happy with that. We want to know that we have the purest signal possible. So what we do is we have this multipath jacks. Now there's two different multipaths on tuners. One is like this tuner has, and shaky cam coming. Right here you can see, I don't know, can you see? I can't see the camera where I'm looking, but you can see right there where it says multipath, you have an X and Y output. Okay, so the real high-end tuners have that. Other tuners have a multipath switch on the front of the tuner. Okay, let me see if I have a tuner that has that, and I'll show it to you. Alright, so we're looking at my SX1050. Okay, and if you look very closely here, you have a switch called multipath. And what it does is it will apply the multipath signal to your tuning indicator, and you can adjust your antenna while this is turned on to null the meter out so that you get the least amount of multipath distortion. So it's like a built-in multipath tuning circuit. So you would turn that on and you would rotate your dipole antenna or move your antenna to get minimal signal interference. Now, that's one way to do it, and it's built in and it's easy and it's really neat. You get to see a meter move around while you move your antenna, and of course you'll hear the difference in the sound. But in addition to this, we have those output jacks, and if you have a fancy device, Pioneer, I did say earlier, I did look it up, Pioneer does make one of these, and it's called the SD1100, SD1100, and I'll pop up some pictures of it. And it's basically a fancy oscilloscope for audiophile people who enjoy tweaking things like that. But you can also connect it to your standard oscilloscope, which I have done up here. Okay, get my camera set. And if you look up here, what you're looking at is a multipath signal coming out of those two jacks. So my scope is set to XY mode, meaning this channel will make applying a voltage to this channel will make the trace deflect up and down, and applying a voltage to this channel will make the signal deflect right to left. Okay, X and Y. And if you look, I have that tone on there. And if we move our antenna around, you see what it does? Till you get a nice Lissajous pattern. See how nice that is? That's a well-tuned signal. That's a badly tuned signal. You see the difference as I move around? And we can get it right perfect. Now, if it's a mono signal versus a stereo signal, that may look different. Okay, but essentially that's what they're doing. It's just a fancy way of being able to adjust your antenna. Okay, so think of the multipath jack or the multipath switch on a tuner as an antenna tuning aid. Okay, that's what it does. And if I tune off frequency, you can see how it moves it around. And I lose my stereo signal. Okay. So, and if I increase my amplitude, you can see how nice and centered you can get everything. And if I change, there's left, there's right. See there? So again, that's really what it is. That's what it is. Mystery solved. We all know what multipath is on our tuner. Okay? And I don't know, you know, I don't keep up with the modern gear out there. There's so much, and some of it is very high quality, very good stuff. And I don't know, but I would imagine that's, you know, some of the higher end tuners still may have that. But of course, you know, I don't know, with these phase lock loop, you know, all the new circuits that they use now compared to this has PLO in it too, don't get me wrong, but you know, some of these new digital tuners that are all digital, they, you know, they do things differently, so they may deal with multipath a totally different way. So again, there's not much to see in the alignment. It's this one is pretty well aligned, so I thought I'd take some time to go over some of the functions that you see on these tuners. This is a fantastic tuner. I hooked this up to my 2 meter ham antenna, because its 2 meter band is, you know, between 140 150 megahertz, 144, something like that, 147, which is higher. Obviously, it's resonant at a higher frequency than the 88 to 108, but it's close enough that that antenna will actually receive FM broadcast pretty well. And when I connect to it, you know, even in the basement here, I connect to that 2 meter outside. You know, being in the hole where I live and everything, this thing just receives, it's so sensitive, it receives all kind of stations. So I know this is a hot receiver, and it's very, very well aligned right now, factory alignment. Nobody's messed with it with the golden tweaker, so really there's not much for me to do. So I hope this video was interesting to all of you. My next video, I do have another receiver ready to go up on the bench, but before I get to that, I will absolutely, I'm getting swamped with comments, so I really have to address those. And I'm going to try to do a comments every month, one a month from now on, and give you, the viewers, an opportunity to participate in the channel. Some of you don't have the time really to put into making videos and being part of the community of electronics and so forth. And maybe this, if this grows, I don't know where it's going to go. I'm just going to let it go in its own direction. And you know, we'll get some of the viewers' comments and questions up there, have some dialogue up there, and maybe it'll be enjoyable for everybody to be able to participate without having to make their own videos and things. I don't know, but we'll see. But regardless, I appreciate all of your wonderful comments. I've gotten so many positive comments and things, and I'm just flattered. I really, truly am appreciative, and I'm glad that my little effort here maybe can entertain you for an hour or two here and there, and maybe you can learn a few things from what little I know. And I know I can learn a lot of things from your comments too, and I have, believe me. I thank you all. And so you all have a great day. Again, I wish you all the best health, the best everything in your lives. And till next time, don't keep the faith, share it with others. And we'll see you next time. Bye-bye.